In this, welcome back to my channel. Today I come back with another this tutorial on fracture mechanics analysis. So, as I told you on the previous videos, we try to see the edge crack by using premished crack, and also we discussed all the semi-elliptical crack. That means somewhat recent version of crack analysis. So in this episode of video tutorial, I'm gonna show you how to extract the fracture parameters on the center crack, a plate with center crack. That means it has a groove on the two faces. It is tall as a circle. I take a square plate with very little thickness. That means you can consider like a paper or a sheet metal with very little, very small thickness. So in this video I'm gonna show you how can you create this geometry by using surface body. Again, how can you select the material for this analysis, and we will create different coordinate systems at the crack tips, and also at the meshing stage. We should I'm gonna give sizing with sphere of influence by selecting the two vertex. We will give sizing, and we use automatic method called dominant for this body discretization. And also in the fracture mechanics, we drag the fracture tool and we adjust the premished crack, and also we create some nodal name selection for directing to a fracture tool. And the static structure level, we put the fixed support on the bottom edge, and also apply 100 kilonewton on the positive y direction. At the solution stage, we try to extract the equivalent stress toward deformation and stress intensity factor due to mode 1. So in this video, as you know the drill, I'm gonna show you how can you do this all step by step. Keep watching. I'm back after a break, and this is the usual workbench window. So to start our analysis, let us drag the static structure to the project schematic window. And so now structural material is default for us workbench. So let us accept that and proceed to the geometry part, or the geometry level. So let us open a new design modular geometry, and then let us adjust our unit and start our sketch. It is straightforward. So let us create the plate. Let us create the plate. And then from concept, let us create a surface from sketch, and let us select the sketch on the base object, and let us give a very small thickness, and let us generate this. The surface body is created, so let us execute this design model and proceed to the model stage. So let us refresh this. Before starting doing anything on this mechanical workbench, from here on the project schematic, from the geometry here, the property of this geometry, we have to change the analysis type from 3D to 2D. and then let us update this one, and then from here the mechanical answer workbench window, let us start our analysis here. So as the first one is geometry, so we create a surface body which assignment is structural steel. You can change if you want to, and from the geometry we have to change 2D behavior into plane strain from plane stress condition. So let us select plane strain here, and then the material general structural steel, and here let us insert coordinate system at the two vertices. So let us select vertex selector here, and let us apply. So this x must be on the reverse direction, so let us change that on the direction of crack, and y is the direction for force. And also let us insert another coordinate system on the opposite crack. Let us apply here. So as x is towards the direction of crack, and also y is in the direction of load, so it seems like good. And then from meshing here, let us insert sizing meter first. Let us hold body selector, let us select this body as a whole, and let us accept. The meter is equilateral dominant here, and let us insert sizing to discretize it around the crack tip. So type is sphere of influence, so the radius of the sphere is 5, and the element discretized by this element size. And then let us insert sizing again, and also select this vertex. So 5 millimeter is the sphere of sphere radius, and the discretized element size within this sphere as this one. And so let us generate this mesh sizing. So as you can observe from here, this is more discretized in final manner around the two crack tips. And then let us create the nodal vertex here. Let us select this by holding the conductor. Let us select all those vertices, and then let us create named selection. And from named selection, let us create nodal named selection, and then let us click on the model and insert the fracture tool here. Let us insert a pre-meshed crack. Let us select the crack tip here, the named node selection, and then at the solution and select the coordinate here. This is the first coordinate, and again let us insert another pre-meshed crack. Let us select this, but the coordinate system is this one. And at the static structure, let us apply as a fixed support at the lower end, and again let us insert the force on the upper vertex here, as this force is defined by components in y direction only. So this magnitude of load is applied on this plate. And then from the solution stage, let us insert the total deformation of the component, and also you can see the equivalent Burmeister stress. And besides this, let us insert a fractal tool here, the crack selection, and again let us insert a fracture tool again. Here the crack selection will be primitive crack tool, and so let us tool those results. So see the total deformation result. It will be maximum at the upper middle tip, and the equivalent stress will be like this as expected. So let us exaggerate the stress distribution at the tip here. So the stress will be maximum as this point with magnitude of 18,246 megapascal around the both crack tips. And also you can see the stress intensity factor added to mode 1 with this magnitude on one side, and again the stress intensity factor on this reverse one will be this magnitude. So the thing you have to understand, or I can give you an assignment, what is the reason why there is two stress intensity factor at the two crack tips. So you have to search about that. So this is how can you do a center crack fracture parameter analysis by using a workbench. I hope you enjoyed by this video. Next time I will back with another advanced fracture mechanics analysis by this software for time now. Thanks for watching. See you.